Hello, everybody. Welcome to the big topic for the chapter, categorical probability. So, right off the bat, we're going to be looking at two-way tables, primarily all the way through this topic. Frequency tables are the simplest form of a two-way table. All that it does is it just counts up how many people are in each category. So, like here, there were 30 people who are in sixth grade and can swim. There are 12 people who are in seventh grade that can't swim. And that's exactly what this whole idea of it's called a two-way table, because it's comparing information two different ways. So there are 12 people who fit into both of these categories. You can imagine this was maybe like a survey that they did. They went around and asked people what grade you're in and whether or not you can swim. And then they organized that information so that it's not just like a big spreadsheet, but they kind of put it into this organizational structure, and we can kind of start seeing, all right, well, there were 96 people in seventh grade that were surveyed. There are 38 people altogether who cannot swim. And it allows you to kind of start analyzing the data, and so hopefully you can make some conclusions, which we're going to look at a couple conclusions that can be drawn from this information today. The first thing that you might do with a frequency table is turn it into a relative frequency table. And what that does is it takes each one of these data points, we call them cells, like each one of these is a different cell, and you divide it by the total so we can see what percent of the population is everybody, what percent of the population is in each category. So like, for example, I'm going to take 30 and divide by 324, and you get these nasty decimals. Just typically round off to 2 decimal points, and remember that's like a percent, so we would be about 9% for the first box. 0.09 is 9%, 9/100ths. 4 divided by 324. That should be a pretty small, about 1%. I'm going to pause the video so you don't have to sit here and watch me do all this division, but just know that that's what I'm doing for each box. I'm taking that number that's in the cell and dividing by the overall total amount of people who were surveyed. All right, so you can see I did all that division there, got all of these decimals. And in the bottom right-hand corner, it adds up to 100, 1, because it's 100%. 10% of our survey respondents were in sixth grade, 30% in seventh grade, and 60% were in eighth grade. 88% could swim, 12% cannot swim. And no matter which direction I add, that adds up to 100%, or 1 if we're using the decimal points. So again, it just allows you to start kind of the most basic version of analyzing your data, breaking it down, and seeing what's going on with this population that we've surveyed. Go ahead and pause and see what you think about number 1 right now. All right, hopefully that wasn't too hard. I actually just paused because I needed to clear my throat and take a drink of water. The percentage of middle schoolers who cannot swim is 12% right there. Right, this is 6th, 7th, 8th grade. Cannot swim total 12. Would be 12% of middle schoolers cannot swim, approximately. Right, all these are rounded. But then the next question is, does there appear to be a relationship between students' age and their ability to swim? Well, there's actually kind of a weird thing, is that if I first look at it, it kind of looks like as we're going, 1%, 4%, 7%, more and more percentages, the higher percentage of students can't swim. But then if I look at can swim, 9, 26, 53, hold up, that's also increasing. So both more people can and can't swim? Well, it's confusing, right? The relative frequency is a good starting point to kind of start seeing what information you can gather about your data. But there is a huge problem in that if your data is not evenly gathered, these percentages aren't super meaningful. And what I mean by evenly gathered is there were 60%, 6 times as many 8th graders as there were 6th graders being surveyed. 60% compared to 10%, 30%. There's so much more 8th grade data than there is 6th grade data. So that's why these percentages are so low and both of these are higher. It's because we just asked more people, 194 compared to 34, right? The population is not evenly represented. And so there's a way to get around that, and it's called a conditional relative frequency. So as of right now, I'm not really sure if there's a relationship. But what the conditional relative frequency table will allow us to do is find percentages within a category. And that's what the condition means. is that we're going to set a condition to say, hey, we're only going to look at sixth grade, or we're only going to look at eighth grade, and find those percentages rather than going and finding the percentage out of the whole every time. 30 divided by 324, 4 divided by 324, 12 divided by 324, always dividing out of the whole. We're just going to look at one age group and find what percentage of each age group can and can't swim. That's the condition. The condition is we're only going to look at one grade at a time. And now, keep in mind, you can go the other way too. You could say, I'm just going to look at what percentage of each grade can swim. Or out of all the people who can swim, what percentage is in sixth grade? What percentage is you can go either direction with these conditions, but for this one, it makes most sense if we break it down by age or grade. So that's what we're going to do. Is I'm going to go through on each one of these, and instead of dividing by a total 324, I'm going to divide by how many people were surveyed just from that grade. So I'm categorizing by grade level, or I'm setting the condition, would be another way to say that, of grade levels. So I'm going to go through and divide this time 30 divided by 34. So just within the sixth grade, put in little parentheses here, 88% of people can swim, and 4 divided by 34, about 12%, which again, now that adds up to 100. That makes sense because we're talking just within this row, that should be 100% of sixth graders. 88% can swim and 12% cannot. Go ahead and pause and see if you can go ahead and do the same thing for the next two, just to get some practice of getting that relative frequency data. All right, so I went ahead and did that for the other ones as well. I even did the total just to kind of really drive this point home, that once we have compared each ability to swim within each grade level, so can swim, can't swim, can swim, can't swim, can swim, can't swim, we find that in each grade level, it's about the same percentage. 88 or 89% of people in each grade level can swim, and 11 or 12% in each grade level can't swim. So once you've done your comparisons, your categorical relative frequencies you found, finding the percentage within a row, or sometimes you might do it within a column. Then once you have it gone that way, you compare across the different rows. And you look to see whether or not those numbers are similar or different. Dramatically different, I should say. In this case, yeah, there's a little 1% variance, but if they're pretty much the same, then we can say that these are independent variables. Which, what I mean by that, independent, is that the grade level and ability to swim is not related. Even though up here it kind of looked like as they got older, more people could swim. Weirdly, also more people couldn't swim. It wasn't really clear. Right here, I can definitively say that because those conditional relative frequencies are similar across grade levels, that means that these variables are independent. Or another way of putting it back kind of in the context of the problem is, without a swimming class, there doesn't seem to be any increase in proportion of students who can swim to not swim. That maybe you have more people that responded about being able to swim, but if you had the same amount in each grade level, not that many people are really learning how to swim. It's about the same across all grade levels. And if we compare that over to Northside, go ahead and see if you can do the conditional relative frequency. So Northside, by the way, if you skip this part, has a swimming class. So I want you to see what it looks like when things are what's called associated, where there is a relationship. Go through and go ahead and find the conditional relative frequency for each grade level. And then we'll talk about what that means. All right, so I'll give you a second. Again, you can pause right now again if you want to just copy these in, but I'm going to talk in now. Okay, so what these numbers mean are 79% of sixth graders can swim, 21% can't swim. And then as we go to the next grade level, there's a jump here, and these stay about the same. There's still about the same amount of people that can't swim, but if we look, they also surveyed more people in the seventh grade than they did in the sixth grade, like 50 more people, like quite a few more. And so it's important that we don't just be like, it's about the same. No, it's really not actually. When you divide these numbers, 138 divided by 161, 23 divided by 161, you look at what percent or what proportion of each grade level can and can't swim, we see that we actually increased the percentage significantly. 7% more of the grade level can swim, and we lost that 7% here. 21 minus 7 gets us down to 14, right? Yes. And so you're offsetting. There is a change in these percentages, unlike how there was here. Yeah, sure, 1%, but that's pretty insignificant. And more importantly, as we look to the next grade level, it changes again. We in 2 years went from 79% to 93% and from 21% to 7%. Those are significant changes. And so what we can say is that as we look across the grade levels, these two variables, grade level and ability to swim, are associated. And we call it associated, even though you might think, well, independent, so dependent, right? Dependent implies that they're causally related, like cause and effect, where you can imagine that if somebody goes from 6th to 7th grade, maybe they still can't swim. In fact, we can see that there are people that continue across grade levels and still can't swim. A dependent relationship would mean that as one thing changes, the other has to change. So, like spending money and money in my bank account. As one changes, the other has to change because that's where the money is coming from. Those are dependent. Here we say associated because, or other times you might call it related, because it tends, as one thing is changing, there tends to be a trend in the other. So it's like temperature outside and ice cream sales. That as one changes, the other tends to change. But it's possible we have a hot day and nobody buys ice cream. That's possible, but typically, hotter the weather, more ice cream. Colder the weather, less ice cream. That's what's happening here, is that when you see those numbers change, when you see the conditional relative frequencies, the percentage of each grade level, and then we look across grade levels and we see those numbers changing, not staying the same, we know that there's some sort of relation going on, or it's called associated. So this is how we can determine whether there is any sort of relationship between these variables, these categories. Just by looking at a simple two-way table and doing a little categorical relative frequency. All right, so let's go ahead and pop back to the backside and do some more pointed questions that deal with two-way tables and also Venn diagrams. So I would encourage you to go ahead and pause and try to work through the stuff on the backside, and then I will go through it with you here in just a minute. All right, let's talk through this a little bit. So when you are starting to pick out probabilities from a two-way table, it's very important to watch what the population is. So like on this first one, when I first started looking at it, it says, what is the probability that a randomly chosen faculty member? So I'm starting to think, all right, randomly chosen faculty member, that means out of the total faculty members, there's 10 males in biological science, 15 females in biological science, 26 education that are males, 21 females in education, and so on, and it adds up to 108. So when I see randomly selected faculty member, that should be my first thought. But then, as I read on, given that she is from biological sciences, that restricts your population down so that I'm only looking at this category. Now the question is really, how many people in biological sciences are female? Or better yet, what fraction of people from biological sciences are female? And the way you can actually write that technically, you'll see this in some of the Khan assignments. P means probability of selecting a female. That vertical line right there means given, or with the condition that they're in the biological sciences category. So given this, what's the odds of that is the way you would read it. So there are 15 females in the biological sciences that has 25 people. So the probability of selecting a person at random and getting a female from that category would be 60%. 15 divided by 25, 60%. Now, the next one, as I read through, what is probability that a randomly selected faculty member is female from education or male from social studies? So there's no social sciences. There's no given here. There's no restriction. This is a randomly selected faculty member. So we will be dividing out of 108. Even though we have two separate categories, we're looking for a specific thing in each category. A female from education. Education, female. That's 21 people. 21 out of the 108. Male from social sciences. Male, social sciences, 19. So there are a total of 21 plus 19, 40 people who satisfy the criteria of being either this or that. So we have 40 out of the total 108 people. If you divide that out, it's about 37%. So if you pick a person at random, you have about a 37% chance of picking either a female who is in education or a male who is in social sciences. What is the probability that a randomly chosen faculty member is from biological sciences, given that the faculty member is a male? So now we're given a row restriction instead of a column restriction. We are only looking at the male population. And we want to know, out of all of the men in this survey or whatever it was, what is the percentage or what is the ratio of people in biological sciences compared to all men being studied. So there are 10 out of 55 if we're only considering the males. Again, we're not dividing by 108 because we restricted it to just be males. So it's just 10, the amount in biological sciences, out of the total number of men, since that was the given population. 10 out of 55, divide that to be 18%. All right, hopefully that's not too terrible. I will say the first time that I did that, I misinterpreted this problem here, and I was thinking about it as the odds of picking this out of here and this out of here instead of this out of the total. So just again, I can't stress enough how important it is to be careful in the way you read the problems and especially the way you interpret what it is that they're asking you for. As always, ask if you're not sure. And maybe, hopefully I'll know. But yeah. Venn diagrams. How many cars have sunroof? So we've got a couple different categories going on here. So these are cars in a car lot. Some have sunroofs, some don't. Some have 2 doors, some have 4 doors, and it actually looks like some have other, which I'm assuming is more than 4 doors. 3 doors seems kind of weird. 1 door seems like the Batmobile. So let's assume that these out here are more than 4 doors. All right. How many have a sunroof? Well, these have a sunroof, but also these have sunroofs. So we have 18 cars, 13 cars, and 20 cars. 18 with sunroofs have 2 doors. 20 with cars have 4 doors. And then there are 13 cars that have more, I guess, than 2 or 4 doors and have a sunroof. So these don't have 2 doors. They don't have 4 doors. They're not in these 2 circles. They're in some other circle that is sunroof, but not one of those 2 amounts of doors. So we just add those together and there's 51 cars that have a sunroof. How many cars have 2 doors and a sunroof? So and is a restrictive quality. It means it has to satisfy both criteria, not one or the other. We'll see that in the next one. So how many cars have 2 doors and a sunroof? Well, 2 doors are all these cars. Sunroof are all these cars. 18 is the only one that fits into both of those circles. So it's restrictive. It took all of these different cars with sunroofs and restricted it down to just the 18 that have 2 doors. Whereas the or statement actually opens up the probability a little bit. So how many cars have 2 doors or a sunroof? Well, now this 14 also is included with the amount that have sunroof. Because if it has a sunroof, it has 2 doors or a sunroof. If it has 2 doors, it has 2 doors or a sunroof. All of these work. It doesn't have to have both. So we have 14, 18, 13, and 20 are all the different numbers of cars that have either a sunroof, 2 doors, or both a sunroof and 2 doors, which and works in the or statement as well. So you can see I added all those together. Now, if you select a car random, what is the probability that it will have more than 4 doors? Again, we're assuming that the ones that aren't in the 2 door and 4 door mean that it's more, not 1 or 3, just for simplicity's sake. So it could have more than 4 doors and a sunroof, or more than 4 doors and not have a sunroof. And either way, it has more than 4 doors. So what is the probability you'll select a car that has more than 4 doors? Well, there are exactly 23 cars that meet that criteria out of, if you add all these numbers up, that is a sample space of 100. So we have 23 out of 100. That is a 23% chance of selecting a car that has more than 4 doors. And finally, a term that you might or might not be familiar with, mutually exclusive just means it can't be both. So you can't have both 2 doors and 4 doors. That's why those 2 parts of the circle are zeros, is because they are mutually exclusive. You can't flip a coin and get both heads and tails, right? Those are mutually exclusive. So just want to make sure you're aware of that term and what it means. But if you have any questions, as always, you know how to get a hold of me. Ask whatever you need. I'm here to help you.